Hello Veritrek Exploration Tool users. In this video tutorial, we will go through a description and a brief demonstration that will explain how and why you want to use the factor sweep analysis feature of the Veritrek Exploration Tool. A factor sweep analysis is most effective at an early stage in the design process. It allows a user to select one input factor and perform a factor sweep in order to determine the trade-offs between the selected input factor and the output responses. Normally, a factor sweep analysis is very computationally expensive and can take days or weeks to perform. However, Veritrek helps overcome this computation cost by utilizing a reduced order model, which allows a user to obtain just as significant results in a matter of seconds. We will now look at the factor sweep analysis feature of the Veritrek Exploration tool. The first step is going to be to set up a factor sweep analysis from the home menu under the video tutorial session that we have already created. So we are going to right-click on Video Tutorial Session, and from the context menu that appears, we are going to select Add New Factor Sweep Analysis. We will then be asked to enter a name for our new factor sweep analysis. I'm going to enter an analysis name and click OK. And there, now we have created a factor sweep analysis. As you can see, there are default inputs and outputs selected, which are already showing a factor sweep analysis plot. However, you can change these parameters to fit your model requirements. You can enter in or change input factors here in the Input Factor pane. You can then select different output responses here in the Output Response pane. The Veritrek Exploration tool very clearly shows how the input factors relate to the output responses. In this case, component interface heat transfer coefficient does not have a significant impact on the maximum temperature of our model. It can be observed that as the component interface heat transfer coefficient increases, the maximum temperature decreases by about 15 degrees, before reaching a minimum and increasing by about 15 degrees. However, if we increase the amount of component power, we expect component interface heat transfer coefficient to have more of an impact on maximum temperature. And that trend is indeed reflected here, as component interface heat transfer coefficient increases, while maximum temperature decreases by about 50 degrees. We can also add more than one output response to the graph to look at two output conditions at the same time. Other factor sweep analyses and runs can be created in this exact same way, and you can take the results from these factor sweep analyses to move forward in the design process. Thank you for watching this video, and look to our other Veritrek Exploration Tool video tutorials for examples using the other analysis features, as well as more general help and explanation of the Veritrek Exploration Tool.